Hey, it's working. Yeah. So, hello. Back after a long while, just waiting for Unity to load up. But yeah. So once that's decided to start working, get on it. Hey, we're live. Okay, so what are we gonna do first? Bit of admin to make sure keep the project nice and tidy, because believe me, you don't want to get a couple of years into a project and have everything be a fucking mess. Uh, Scripts. It looks like it should be okay. Stream. So first thing we're going to do is create sort of like a basic sort of physics movement script, so we can sort of apply it to any object we want. So like people, uh, projectiles. Yeah, they're two examples I've got. So uh, move, so just so people who watch it know, this is going to be more of like a playing around, making it rather than the actual tutorial, and then I'll edit it up with explanations of everything in a more concise format than me just rambling and working out how stuff works and making it good, I guess. So yeah. Move OBS out of the way. Everything's deciding to be slow as balls today. So well. And yay, or almost. If it wants to work, that'd be nice. Why haven't you opened the script? There we go. So, what do we need? 2D. So I'll just say that, and for convenience sake, do require component, rigid body 2D. Oh no, it's type of, isn't it? So now we can't have this without a rigid body. That's good. Awake. Rigid body. This the get component. Rigid body 2D. Okay. I can hide it, that's fine. Oh yeah, so the basic one first. Move object. Free direction. So actually we'll just add summit here. So if we do serialized field, we can have summit display in the inspector without it being public. So I have a float for max C and have that to like 5. Rigid body, add force, direction. Node 2D dots force, why not? We're using a SMAS, it'll be all physicsy. So that is a scientific term. So if rigid body dot velocity dot magnitude. So velocity dot magnitude is basically just like its speed as one number, but you can do like velocity and have the actual vector, so you know on the x and y how fast it's going. Is less than max velocity. I'll just add that. Okay, so that should work. So 2D object, sprite. Just gonna make some basic shit to just demonstrate that it works. How's that look in the world? 5, 5, 5. Make that red. So I'll move a couple of these round so we have something to save. And have one for the object we're moving. Just move that back to white. And since we have the required component, it just adds object mover. Or if we have object mover, it has to add rigid body 2D. So that's a little bit of a time saver. Convenient. So mass, fine. Should be okay. I'll just check the physics because I don't know if it'll be, because it won't think it's top down, will it? Physics 2D. Our gravity is. Oh yeah. Okay, so we can't have gravity because it basically treats the sort of y-axis, so this, as sort of up and down. So if you were like playing like a Mario sort of side-scrolling type deal, that'd be gravity. But since we're doing top-down, gravity is like towards and away from the camera, so I can't do that. And now we are going to make a quick input script. Input manager. So there we go. Fields, key code, forwards, backwards, left, right. So I'll just have those there so that we can change the keys as and when we need to. So, object mover to move. Awake to move equals this to get components. Object mover. What else? Fixed update. So, what fixed update is an update that gets called every time the physics updates. So, if we're calling something like move object, where we are actually applying physics to the object, we want to call it there. So, if input, actually, do it as our method, void, free, gets input for movements, it's free, let's val equals 3.0, return, val, so if input get key forward, val plus equals, actually no, just do normalized there. Val plus equals new. I don't know why I'm doing vector 3, it's vector 2, isn't it? Because it's 2D. Sorry, I'm making a lot of 3D games recently. So it's just a habit. But yeah, I don't think it matters that much. Just a bit of a waste. Vector 2. So 0 and 1. If import, okay, key backwards. 0 minus 1. If left. So that'd be minus 1, what? No, 0. And finally, if input key right, let's val plus equals 2, 1, 0. So basically what we're doing here is we check for all the input keys we defined, and if we do, we add the corresponding sort of translation to what we're returning. So by doing it this way, we can have basically, if you pressed forwards and left, we get sort of like a diagonal movement without having to define like if forwards and left. And if we like hold forwards and backwards, we can just go nowhere. Yeah, and we normalize that because technically moving diagonally would be slightly faster than just moving in a single direction. I'm pretty sure that's a bug that gets used in speedruns sometimes, but yeah. Whatever. That's fine. So, to move, dot add, dot move object. Get input for movement. And if to move, just rename that. Input manager. So W. Oh God, go find it in the list, don't I? S A and D. No, that's gonna go delete, so I have to scroll again. D. Okay, so this should work now. Hey, so there we have some basic sort of physicsy movement. And I think if we add some drag to it, it'll eventually slow down and stop on its own accord. Yeah, physics. Now, what I want to do is just add to some box collider 2Ds to everything. I should have added to that as well. So yeah. So, since we're using the physics, we can now collide with stuff, hopefully. Yep, collision works fine. What was I going to say? Yeah. So the reason we're not using something like transform.translate for this is that it's technically not tied to the physics. So it'll move the object fine, but it will like jitter as it collides with stuff because it's technically moving into intersecting the object's collider. Then the physics has to calculate like how to get it out again. So it keeps trying to throw it out, and then when you're still moving, it moves back in, and so forth, and so on, so on. It looks bad. So this just looks a bit smoother, and we can have that. And even despite the rotation, it still moves in the same direction, so that's good. So yeah, what else now? So we're going to do. So I got the movement down. Basic camera controller and player rotation is the next topic I had. It's fine. So I'm gonna add this to our object mover again. So public void face point 3 point to face this dot transform dot look at face, that's fine. We are also going to make a quick camera controller class. So I'm going to define a camera controller me public static controller me if me equals null, find object of type camera controller, return me. Alright, so what this is basically a singleton. So you have, if you have one of an object, you just basically store a static reference to itself, and then it's easy to find. So basically, static object here. We can call this from anywhere without needing an object reference because it's static. If it's null, it'll use find object of type and cache it. So we only need to call that once because find object of type is kind of expensive, and then it returns it. And for similar reasons, camera main cam. We are going to do the same for main camera because calling camera.main actually uses find object with tag for the main camera, which is not particularly efficient. So yeah, camera get main camera main cam null main cam camera dot main so main cam No. Okay, so for our input manager, we are going to make something so that the little cube boy we have will rotate towards the mouse a la any top-down shooter we played. Void mouse imports, I guess. That should be a vector 2, shouldn't it? 2 mouse in world equals camera controller dot me dot main cam screen to world point imports dot mouse position and to move dot face point mouse in world. Okay, so what we're doing here, we get our camera controller, we get the main camera, we convert the mouse's screen coordinates to a world point, so that'd just be a point in the world. Then we say that we want our object stored under toMove to face that, and since this isn't, it's not, the words are failing me, it's not specifically tied to the physics, since we're just saying, alright, we want you to look at this point instantly, no consideration for physics or whatever. So we probably could do it with the actual, rigid body, but we're not going to. So we can just do it in update instead of fixed update. Fine. Camera controller. So what I'm going to do is make toMove a bit wider just so we can get an idea that it's facing the right way. So forwards axis is, I'm assuming that's Y, so hopefully that'll be the right one. That wasn't what I was expecting. Has it just... Yes, it's using the wrong axis. It's using the Z axis, which is always fun. Okay. This involves maths. That's not fun. This dot transform dot Euler angles equals new x3. This dot transform dot Euler angles to x. The y. So this is probably a bad way to do it, but let's cheat to see if that will just fix the problem. Nope. I mean, the x looks like it's working from the numbers we can get. So let's just see if making it 0 on y works as well. So we only need one axis of rotation. Okay. Do okay, back to the drawing board for that. First, I'll just find a look at. Oh, I'm missing something. Oh, okay, that's one. Okay, point to face, and our weld up is 3 dots forwards. So, guessing that I do it right. Now that we've specified that our up is no. Of course, it wouldn't be easy. Oh well. Let's Google it. Because that is the best thing you can do as a programmer, is learning to Google stuff to fix something. Okay, so thank you, Google. Okay, so we've got our point to face. Look, bars equals point to face minus this dot transformed position. Don't know why I did that there. Look, bar. Oh, Quaternion Q equals Quaternion dot look rotation. Look bars. So this is just something I'm copying off the Unity forums. Rotation equals Quaternion dot slurp. Form dot rotation. To Q time delta time times, I don't know, let's say 5 just for some speed. So hopefully that'll rotate towards the right point on the y-axis. Okay, so we're almost there. Leave. No, because we want to rotate on the z-axis, because I'm a dumbass. Oh well. So yeah. So we just set the z to 0 instead. Hopefully, that'll be the easy solution. Because a lot of my maths is guesswork. It's sort of working. I don't know what the fuck is going on. Z. Quaternion.euler 0 0 q.euler angles.z. Who doesn't love a bit of guesswork? Nope. Alright, second solution from forums. Third time's charm. I mean, it's backwards for some reason, but it's almost there. What if I just multiplied it by -1? That seems so stupidly simple, it might actually work. It did. Okay, so let's check. Yeah, that's the right axis I wanted. So the Y is facing. So credit where credit is due. On axis from so yeah, there is a reason that I don't really like maths, just because I'm bad at it. So I'm assuming that you could just Google what math.atantu does, because I'm guessing it just calculates an angle, or in radians, and then you convert that to degrees, and hey presto, you have your thing and you invert it, so it's sort of the right way. Now, just start the camera controller. So we've got movement. So I'll just check, how does that work with the movement? So that works fine. I suppose. So if I just do that, yeah, it just sort of bumps you off, so that's fine, it's not breaking anything. Alright, so camera controller. Ball. I just need to ball. Follow targets. No, it should be how for player. Transform player. Update that. If follow player, if I can spell this, transformed position equals new vector 3 player dot position dot x player dot position dot y and start transformed dot position dot z, because we don't want to zoom the camera in, we just want to move it with the player. Need a capital F, because we pay our respects here, boys and girls, and I don't know, we only got one viewer, so either or, I guess, or non-binary, or whatever. Yeah, so we are doing that. Follow player, just need something to set the player now, so public void set player to follow. Player equals T, and then just do camera controller dot me dot set player to follow this dot transform just for the time being. Now we can see that the camera follows us and our slow movement. And even if we get like nudged by them, it doesn't fuck up the camera. That's good. So got a basic camera movement. What's next on the thing? Visuals for humans. That's fun. We need a graphics thing. So where's a Sprite? There we go. Ah. So since I'm not an artist, I'm just going to create something really basic to get how I'm going to sort of do this across. So just have a basic sort of blue jeans. So this would be the calf. Something a bit bigger for the thigh. Lighter looking trainers. I'll give them some Air Force Ones. Murkier looking t-shirts. Do that and that. Let's give them a second leg as well. Also do arms. So that'd be forearm, upper arm, skin tone, and just give him a bald fucking cram down, and just so it can be funny, a little shiny patch. There we go. That's that. So file, export sprite sheets, export. No, I don't know how to write that. File, save as. Go. That's not the right project. Documents. Top down, top down, top down, top down. Shooter. There we go. Assets. App. Export that. Hopefully that's put it in the right place. Yay! Okay, so we're going to have basically 25 pixels per unit. No, we're not. Actually, yeah, we are. Whatever. Points. So that's alpha transparency, physics shape. We don't care. Multiple because it's a sprite sheet. Compression, that's fine. So yeah, so little tip for art: if you want stuff to look pixel arty, you need to switch to a point filter. What else? Sprite mode, you can just go to single if you're having one sprite, multiple if what's the word? It's a sprite sheet, so this person is going to be multiple for a reason I'll explain in a sec. And polygon if your sprite is not a square or a rectangle. Yeah. And other stuff like that. Alpha is transparency, so if you just leave alpha in your image, then you can have that as transparency, or if you are struggling for space, so maybe if you're on a mobile platform or something, you could leave the alpha channel from the image entirely and save like 25% of the space and just have like a color to take out. So you do that via a shader, and that would save you some size on the images. And things like bilinear and trilinear, they're just filtering, so they can sort of smooth out the edges if you are not doing pixel art. Yeah, let's go into Sprite Editor. So, what we're going to do now is use these nice automated slicing of. Well, it almost did it. So basically, you can like sort of guess how your sprites are supposed to be. So you got most of them right. So I think it just needs to do the ands, which should be fine. But yeah. So what we're going to do is move some pivots about. So no, that should be right center. Right center. Right center. Right center. Right center. And right center. That should be bottom center. Bottom center. Bottom center. Bottom center and bottom center. So there we go. That can be in the center, that can be in the center. Alright, we're all good for sprites. So my idea is this should be okay. Just zero that out. So what we're gonna do is have stuff attached to here, so that'd be the person. So what I need is his thighs. So that'd be and left thigh. So that'd be 2, 1, 1. What we do, we take the calves, and make them as children, so we can just zero them out. And that's not nice. 0. And there we go. Let's make those. That should be 3. These should be 2. Size 1, and the shoes are 0. That's calves. I didn't move the left calf, the right calf, did I? Oh well. 0, 0. There we go. So that's right foot, left foot. And where do we put the arms? basically just going to make this little dude T-pose for a second. So that's left forearm. No, it's upper arm, isn't it? And got a hand. Although I think I can just do that and do -1. Yeah, boy. Easy peasy. Right, savvy. From forearm and right hand. And finally, we'll stick this dude's head on. So, no, that should actually just be 4. Yep, 4. So the reason we built the dude like this is so that stuff like, or the sort of all the body parts are sort of easy to animate. So you can do stuff like rotate this arm, or we'd do this in the animator initially. But yeah, you can see even if we rotate this arm, all the other bits go with it. Same with the person. So yeah, you get the idea. Basic rig. And if we, where's the animation? We can start creating animations for the dude. Create app, new folder. Shortcut, no. Where's the folder? New folder. Walk. There we go. So with the with Unity's like animation thing, if we just click record, what we can do is just move the dude's parts, and that'll record an animation that we can then play back because it's easy. So what we're gonna do? Right thigh. So we're gonna do that. We can actually probably cheat. So I'll just do. So if we start like with the scale being 0, and then if we like move to the frame at 1 second, we just do no. Oh god. So I think if we just move that to -1, and then move that to 1. And likewise, we go to 2, we go to -1, and 1. That's 12. That's not what we want. Yeah. And we don't want that. So why is that moved? Get rid of that. And then just copy that first frame we did, move that to 3. We will have a badly sort of rudimentary walking animation. I don't know if we just do something like this. Just copy this frame here to there, and if we move everything towards the start, it'll look even better. There we go. We're walking. Okay, so just gonna animate the arms for the dude. So that was the left one. So I need forearm. You just rotate that there. Right upper arm. Forearm. Let's do the upper arm a bit more. Oh shit, yeah. Need to fix those first. So that should be like. These sort of should all be like the same, shouldn't they? Just like 4. They appear over the legs. That's there. So as we do that, we want to change the rotation of that to there, and that to there, and as we go there, do that one out, that one there. How does that look? Yeah, that looks fine. Yeah. So we've got one. We've got walk animation. Let's do a new one for idle. So for idle, we're basically going to set the thighs to be like 0.1, just so he's standing. We're going to rotate the arms so that he's sort of like arms crossed looking sort of thing. And yeah, so where can I? And yeah. So if we just adjust the scale slightly. No, I don't want X. Is it Y we want? Yeah. So 0.01. If we do that, then over that we want to adjust to like 0.05. And then over the second, you know what I mean. I want to go back to 0.0. So now we've got a little sort of standing around, idle, sort of breathing dude animation. And yeah. Looks good. Or as good as my artistic ability allows. So now that we've got 2 animations, we need an animation controller. So I'll just create a animation controller. Animation person. There we go. It creates one for us because the game is just good like that. So we want to set this as the layer's default state. So this basically is the default animation that it'll run to when a thing starts. We can also add parameters here. So you get your basic data types. So in this case, we want a float. We'll call this move speed. And So let's say if move speed is greater than 0, we want to go to walk and make transition. And if its move speed is... you can't do equals for a flow. That's annoying. How do we do that? Yeah, I just set it to -1 if the I don't know. If I set it to like move like as the velocity minus something, minus like 0.01, hopefully that'll work. So does that loop by default? Don't know. That's not what I wanted. Yeah, it loops, so hopefully. Right. So I'm going to delete that and move our to move stuff to the person. Move object mover. No gravity and a bit of drag. Then once I shouldn't have deleted the fucking input because now I have to find things, don't I? Where's that? I'll just drag you over so I don't have to find everything again. And then object mover. So no gravity and some drag. I'm going to just delete to move there. So now, if we press play, see we've got a dude on his little idle animation, and we can move. Nice. Right. So let's create another script for our person animation controller. Now we need mono behavior. So it's what? The animator? I'll grab off this to set this off. Yes. So animator, my anim. So we're going to want to get, I'll have a method here to get the velocity. So public float get object speed turn ridge body dot velocity dot magnitude animator dot set float. What did I call it? Because I have a memory like a colander. Move speed. That should have made some move speed. Probably end up moving this out, but for the time being, I'm just going to store a reference to object mover. Object mover. Object mover equals this. Okay, component. minus 0.01. So actually, I'll just add a quick box collider to this as well. Box collider 2D. Yay. Follows a physics shape, because that's wonderful. So box collider, animation controller. So if I'm right, yeah, now that it's got momentum, it uses the walking animation. Although it hasn't stopped, which is annoying. Oh no, it has. It's just needs to be a bit more sort of a bit bigger. So I'll do minus 0.1. See if that gives us a better result. And then, like in that tree that you showed me, sort of setting the values first, you could add like if value is more than whatever, you do like a running animation. I wonder if I can change that, because I think it's based on the exit time. No, so we can just sort of stop anywhere in this. Otherwise, there. So I think that might solve the problem of it being a bit delayed or having to wait for the end of the animation to change. So. Okay, that looks okay. Just need to make the move speed a bit faster. Or max velocity. What's that? And add an acceleration. Direction times acceleration. Time dot fixed delta time. So yeah, fixed delta time is just the update rate for the physics system, as opposed to delta time, which is just the rendering. Although I will be replacing that with some kind of simple delta time manager soon, because what is it? It's like you can set the scale manually for different types of things. So you could say what's the word? If you have it like passing it through something that just captures the delta time and then multiplies it by its own sort of scalar, you could have like slow-mo effects without having to like compromise on say like menu animations if you had them based on time.delta time. So it's just a simple thing that gives you a bit of flexibility, which we can do, but for now it should be fine. No. What I've done is just made this dude slower. Like 200. Bit more drag because I want these sort of like instantly stop. Yeah, that works. Okay. So that's animation, basic animation stuff. How long have we been streaming for anyway? Don't even know. An hour. I might actually call it a day there. Alright progress I've made. I'll edit those up and turn them into a proper video. So yeah, that was my sort of return to making YouTube content, I guess. I hope you enjoyed. Any feedback or anything, just give us a shout in the comments. Hopefully you'll see this edit up. I'm going to try and go for a sort of shorter format because I kind of prefer sort of short tutorials. So I'll try and keep the videos where I talk about the stuff in here shorter than 5 minutes, or like a 5 minute max. So hopefully it'll be easy to watch and go back to. But yeah, cheers for watching and goodbye.